Jai Bharat to all students. In last 3 to 4 lecture, we have discussed about introduction of graph, and we have seen number of definition related to graph. So now in this lecture, we will discuss about metric representation of graph. Okay. In first and second lecture, we have discussed revision of matrix and vector. Okay, so now we will require the basics of matrix in this portion, metric representation of graph. Okay, so today's lecture we will see how can we convert graph into matrix form, and we will discuss also some example related to metric representation. Okay, so they have given some matrix and you have to convert them into graph, or they have given the graph, or you have to convert them into matrix form. Okay, vice versa. So first of all, let we discuss revision of last lecture. Then we will start with our topic matrix representation. Okay, so in last I think we have started with yes, adjacency and degree of vertex. Okay, so let's take a quick revision, then we can start with the matrix representation. Okay, we said that two vertices V and W of graph are adjacent if there is a edge VW joining them. Okay, so we have one common edge between two vertices, so it's called adjacent vertices. Okay, and V and W are then incident with such an edge. Okay, we also say that two distinct edges E and F are adjacent if they have vertex in common. Okay, these two edges have vertex in common, like just say P. Okay, so one vertex is common between two edges. Okay, so it's called adjacent edges. Adjacent means nearer vertices or nearer edges. Okay, nearer vertices means they have common have common edge joining them, and adjacent edges means one vertex is common between two edge. Okay, then we have discussed how to calculate degree of vertex. Okay, degree of vertex is a number of edges. Okay, we have to calculate number of edges. Okay, for particularly vertex. Okay, and if it is a loop, then you have to count as a 2. Okay, so these two are the condition. Degree of vertex means only count the number of edges for particular vertex, but if it has a vertex has a loop, then we have count degree of vertex, we have to add +2. Okay, and then we have seen two different definition. If vertex of degree is 0, then isolated means far. Okay, isolated vertex, and a vertex of degree of 1 is called n vertex, last vertex. Okay, which has only one edges, so degree of vertex is 1. Okay, let's say this for this vertex how many edges are there? 1. Okay, so degree of vertex is 1. For this vertex, how many edges there? 1 and 2, so 2 2 2 and again 1. Okay, so these two vertex which has a degree of vertex as a 1, it's called n vertex, last vertex, n vertex. This vertex has a 2 edge, 1 and 2, so degree of vertex 2, again 2, again 2. This has only one edge, so these both are the n matrix, n vertex. Okay, little bit complicated. For U vertex, how many edges? 1, 2 and 3. Z, only one edges. W, 1, 2, 3, 4, 5, 6. And V. Okay, common edge 1, 2, 3 and 4. But here we have 2 loop. Okay, so for loop we have to count as a 2. So here is a 2 loop. So 2 plus 2 4, and total is 8. for this graph, degree of vertex for v vertex, degree of vertex is 8. Okay, so like this you have count, and if you want to write down, you have to write down in sequence. Okay, in ascending order, increasing order, ascending order. Okay, like this: 1 1 2 2 2 1 3 6 8. Okay, 1 3 6 8. Okay, then we have seen one theorem, handshaking lemma. Handshaking lemma say in any graph the sum of all the vertex degree is even number. Why even number? Because we have count, this edge is count 2 times. Yes, one with this vertex, one with this vertex. Okay, so all the edges are count with 2 times. Okay, because they have 2 vertex. Okay, so for v vertex this edge count as a 1, and for u vertex this edge count also as a 1. Okay, so for any number of edges we have to count 2. So if we add all the vertex degree of vertex number, then it's even number. Why? Because it count as a 2. So any number multiplied by 2 it is also always even number. Okay, and then theorem 2, same as this theorem. In any graph the number of vertices of odd degree is even. Okay, number of vertices of odd degree. Okay, odd number. So then we have add, then it's a even number. Okay, so odd degree is even. So these two theorem we have seen. Then subgraph H is subgraph of graph G if each of vertices belong to the V of G and each of its edges belong to the E of G. Okay, it's mini part. Subgraph means mini part. Vertices are same and edges also is same. Vertices and edges is same. It's called subgraph. Okay, so let's say this is a graph. So if you can put like this, yes, this is our, you can put like this. Okay, so this is the subgraph of this graph. Okay, this H graph and G. So H is called subgraph of G. But if let's say this is a V graph, it is not a subgraph of this. Why? Because here they have not given any vertex. Okay, so we cannot do not draw in like this. Okay, all the vertex and all the edges. You can also obtain subgraph by deleting edges and vertices. We already seen. Okay, if we delete these edges, they are we have obtained this graph. Okay, so this graph is also a subgraph of this. And if we remove edges, it's called G minus E graph. Okay, so let's say if this is a F, edge is F, and we have to remove F edges, so our new graph will become like this. Okay, and its graph is called G minus F. Okay, so if you delete any edges, then that graph name should be like this, G minus E. Okay, now let's say if I delete vertex. Okay, here this graph we have deleted edge. Now let's say we want to delete vertex. Okay, here they have delete vertex V. Okay, so you have to delete all the edges in connect with the V. Why? Because edges are not alone. Okay, for edges 2 vertices are there. Okay, so we have to remove all the edges connecting to that vertex. Okay, so they have removed all the edges connected to that vertex. Okay, and it's called G minus V. Okay, so if we remove edge, then we have to only remove edge. Now if you want to remove vertex, then you also have to remove edges related to that vertex. Okay, now complement of simple graph. Okay, complement means we already discussed in matrix. What is the matrix of complement? A dash. Okay, or you can say a bar. Okay, so complement is means simple graph with a vertex V of G is complement. G bar is a simple graph with vertex V of G in which 2 vertices are adjacent if and only if they are not adjacent in G. Okay, we already discussed in previous that what is adjacent, okay, they have edge joining them. Okay, so what the new graph will become, if there is a no edge between two vertex, then we have to draw edges between that type of vertex. Okay, so here we have do not have any edges joining u and v vertex, so we have to connect u and v. Okay, now here v and x also do not connect with one edges, so we have to connect v and x, also x and u also. Okay, so we have to connect, and also y and w. Okay, means complement is its reverse graph. Okay, so if there is a edge between two vertex, then in complement there is a no edge between that two vertex. If there is a no edges, then we have to draw edges between that vertex. Okay, now let's start with our topic of matrix representation. Okay, although it's convenient to represent a graph by diagram of point joining by line, okay, such a represent may be unsuitable if we wish to store large graph. Okay, if let's say there is a large graph and we have to store that data, that which vertex is joining with which edges. Okay, so we have to store large data. Okay, but if we convert that graph in matrix, okay, so we can store many matrix. Okay, in a computer, one way of storing a simple graph is by listing the vertices adjacent to each vertex of the graph. Okay, let's say let's take vertex u. Okay, so u vertex jm, which vertex are joining with them, which are the adjacent vertex which have common edge. Okay, v and u, v and y. Okay, now let's take next vertex v jm, which edges are connecting with v vertex, w, y and u. Okay, so u, w and y. Okay, okay, then next vertex w. So what are the edges connected with the w? One is v, one is y and one is x. Here you can see that vx, y. Then x is connected with the y and w only, and y is connected with u, v, w and x. All other vector vertex is connected with the y. Okay, so this is a one method to represent a matrix by representing a graph like this. Okay, now let's say if you want to store a matrix as a graph. Okay, so there are two matrix you can store for convert the graph into matrix. Okay, one is adjacency matrix and one is incidence matrix. Okay, let's say what is adjacency matrix and what is a incident. Okay, first of all, one condition are there: graph is have to without loop, then you can convert graph into matrix. Okay, so first of all, one condition is there that G is the graph without loops. Okay, and vertex is labeled as a 1 to n. Okay, here we have vertex labeled as a UVW as a ABCD. Okay, but for the matrix represent, you have to label vertices as a 1 to n. Okay, so here 1, 2, 3, any number you can write down, but you have to write down in a number form. Okay, starting with the 1. Okay, then if there is n vertex, then if you want to convert matrix n, then new matrix will become n into n matrix. Okay, let's say for this graph, here is a 1, 2, 3, 4, 5 graph. Okay, so if you want to transfer this matrix into graph, then our matrix should be 5 by 5. Okay, we have to know that how many row and column are there to convert graph into matrix. Okay, so if there is a 5 vertex, then matrix should be 5 by 5. If there is a 4 matrix, 4 vertex, then matrix is 4 by 4 matrix. Okay. Now, how we have to get the number in matrix? Okay, so first of all, adjacency matrix. Okay, adjacency matrix A is the n by n matrix whose ith and jth entry is the number of edges joining vertex I and the vertex G. Okay, you have to calculate number of edges. Okay, if this definition is a little bit difficult, so we can start with example so you can get the better idea. Okay, we will start with this example also. Okay, here we have given 1 2 3 4 and 5. Okay, we have given the number. Okay, now we already know that matrix would be 5 by 5 matrix. Okay, we have 1 2 3 4 and 5. Here also 2 3 4 and 5. 2 3 4 and 5. 2 3 4 and 5. Okay, this is a 5 by 5 matrix. Okay, now what value we have to add that matrix is complete? Okay, for let's start with the first matrix. Okay, now in matrix we have given the name. Okay, like say this is the first row, first column, so we have write down like this. Yes, do you remember this? 1 1 first is a write down as a row, and second value is write down as a column. Okay, now let's say if you for this number it's called A. Here is the first row and fourth column, A1 4. Now here this is like a third row and a third column, A3 3. Okay, first you have to write down row and column. Okay, now here. Okay, now and this is called a 5 5 5 fifth row, fifth column. Okay, now we have to put the value in all the spaces. Okay, so matrix can be complete. Okay, first of all, this is called 1 1. Okay, here 1, and here we do not have any loop. Okay, so number of edges, we have to only count number of edges. Okay, so number of edges count with the 1 1, it's 0. Then here it's called 1 2, first row 2 column. Okay, so number 1 is here, number 2 is here. How many edges are there between 1 and 2? 1. Okay, here 1. Yes, you have to only count number of edges between them. Okay, here our third space is first row, third column. So here what is the number how many edges are there? 1 and 3 between. Okay, there is no edges. Okay, so it will become 0. Yes. Okay, and now A1 4, first row, fourth column. Okay, here 1 is there and here 4. How many edges? No edges, 0. 1 and 5, 1 edges. Okay, so only you have to count the number of edges between them. Okay, but with the help of this first row, second row, first column, second column. Okay, you have to count as a first row and second column. Okay, now let's say second row and first column. Okay, so our second number is here, second row and first column. So how many edges there are there between 2 and 1? 1. Then second row, second column. Second row, second column means 0. We do not have any loop. Second row, third column. Second row and third column, 2 and 3, 1. Second row, fourth column, 2 and 4, 0 edges. Second row, fifth column, 1 edges. Third row, first column. Third row here, first column, no edges, 0. Third row and second column, 1 edges. Third row and third column, so 0, we do not have any loop. Third row, fourth column, so 1 edges. Here we have only have do not have multiple edges. Okay, so our matrix represent should be 0 and 1 also. Okay, so let's start with this given example so you can get the better idea. Okay, adjacent matrix. Okay, here they have given vertex name as a 1 2 3 4. Okay, here our first 1 1 matrix 1 1. Okay, first row first column. Okay, so 1 1 with no loop, so 0. Second, first row second column, we have number of edges as a 1. First row third column, first row and third column and no edges are there, so 0. First row fourth column, first row and 4 1 edges are there. Okay, number of edges, you have to count number of edges. Okay, second column, sorry, second row first column, so how many edges are there? 1. Second row second column 0. Okay, so you can see that here all the diagonal value should be 0. Why? Because it's a second row second column, third row third column, fourth row fourth. Here we have to one condition is there is a with no loops. Okay, so if we want to convert graph into matrix, then all the diagonal value should be 0. Okay, there is no edges between 2 and 2, 3 and 3. Okay, then second row third column, second row and third column have edges 1. Then second row fourth column, second row and 4, here we have 2 edges. Okay, so number of edges is 2. Simple. Okay, so simple, we have to count number of edges between two vertex with the help of matrix representation. One row first column, second row second column. Okay, let's say these two. Okay, so how many this is a fourth row and second column. Okay, fourth and 2 edges. Okay, yes, we got the right answer. Okay, so this is a matrix represent adjacent matrix. This is called adjacency matrix. Okay, now let's incidence matrix, second matrix, representation of second matrix, incidence matrix. Now, okay, now here we have write down a number of vertex is a 1 to n. Okay, also we for incidence matrix we have to write down edges with the label as a 1 to m. Okay, here the edge is 1 2 3. You can write down anything like 1 2 3 4 5. Okay, anything number, but you have to start with the 1. Okay, so here for figure, you first of all you have to give the name of vertex and edges as a 1 to n and 1 to m. Okay, so incidence matrix will become n by n, n by m. Okay, here we have 4 vertex. How many edges are there? 6. Okay, so 4 by 6 matrix is generated with it for incidence matrix. Okay, here in adjacency matrix we have to only calculate the vertex, so our matrix will be 4 by 4, only n by n, but for incidence matrix generated is n by m. Now what are the value of n by m? Whose I and jth entry is 1 if vertex I is incident to the edge j. Okay, here we have only 2 entry, 1 and 0 for in incidence matrix. Okay, so what will they say? That ith and j term will be incident to the edge. Incident means near. Okay, okay, so let's start with example so you can get the better idea. Okay, let's start with our here first row first column. Here it's called I and this is called j. Okay, so definition says vertex I, we have to calculate vertex I. So 1 is a vertex and edge j. edge, one is vertex and second is edge. So you have to calculate say that row as a vertex, column as a edge. Okay, so first row, first column. Okay, and you have to check incident. Incident means near. Okay, first number vertex and first number of edge. Okay, so this is the incident. It's connect with the vertex and edges, so it should be 1. Okay, then first row, second column. Okay, here our vertex will remain same, vertex is 1, but our row is 2, so edge you have to calculate edge as a 2. So this is not connected, one number of one vertex and second number of edge. Okay, so 0. Then 1 and 3, one vertex, number 1 vertex and number 3 edges. Okay, you have to take I as a vertex and J as a edge. Okay, here 3, number 3 edges, so it's 0. Then again one row, fourth column. Okay, one vertex, fourth number of edge. Okay, so this is a connected. Okay, so it's said 1. Then 1 and 5, 0. Okay, this is not connected, and 1 and 6 also 0. Okay, so get the idea. So you have to check vertex and edges is the connected or not. If it is a connected, then you have to write 1. If it is a not connected, then you have to write as a 0, 1 and 0. Okay, but in adjacency matrix you have to calculate number of edges. Okay, so value should be 3, 4, anything, but here incident matrix you only have 2 value, 1 and 0. It's either 1 or it is either 0. Okay, let's say second row. Okay, this is a second row, first column. Okay, so you have now we have vertex as a number 2, second vertex, and edge as a 1. Okay, this is connected, so 1. Second vertex, second edges, this is also connected, 1. Second vertex and third edges, this is not connected, 0. Second vertex and fourth edges, this is also not connected, 0. Now second vertex and fifth edge, it's connected, 1. Second vertex, 6 edges, it is also connected, so 1. Okay, so this is called incidence matrix, adjacency matrix and incidence matrix. Okay, so this is a metric representation of any graph without loop. Okay, you have to remember condition, graph G is the without loops. Okay, now here it is your today's question. Okay, write down adjacency and incidence matrix of given graph. You have to write down draw adjacency and incident matrix of given this graph. Okay, in next lecture we also discuss this topic again. Okay, so if any doubt you can message me. Okay, for this particular topic. Today this is your assignment question. You have to write it down in page or book and upload it in RNWIET application. Okay, adjacency and incident matrix of given graph. Okay, so now today's lecture is completed.